Picture yourself as a developer or system administrator in the early 1990s. You've just bought a shiny new network card or a cool piece of hardware, only to discover that your entire operating system doesn't know what to do with it. The only solution? Recompile your whole OS kernel, an arcane, time-consuming ritual that risked instability or total system failure. Every small tweak or update was a gauntlet, making operating systems rigid and intimidating for users and developers alike. But then, a quiet revolution began. Out of the chaos, engineers introduced the concept of kernel modules, tiny, autonomous code units that could be loaded, unloaded, and updated within the heart of the operating system itself, all without rebooting or rebuilding the core. This was an audacious idea. What if the operating system wasn't a solid wall, but an expandable platform to which you could add new powers and plugins at will? Kernel modules, also called loadable kernel modules, LKMs, are code components that run with high privileges directly inside the OS kernel, but can be dynamically inserted and removed while the system is running. Think of them as USB drives for your OS's central nerves. Snap them in or out as needed. Instead of baking every possible driver or feature into the core, modules let developers and users hot swap support for new hardware, security features, or experimental protocols. You want to add a scanner, a new file system, or cutting-edge encryption? No need for a deep system overhaul. Just load the right module. Before kernel modules, making your system recognize new hardware was often a tedious process involving hours of compiling and testing. The system had little room to adapt or grow once shipped, and vendors struggled to support an ever-expanding variety of devices. The rigidity stifled innovation. The arrival of Linux in the early 1990s and similar modernization in Unix-like systems embraced modular kernels with unparalleled enthusiasm. The Linux kernel's insmod, modprobe, and rmmod commands let any user with the right privileges seamlessly add or remove capabilities instantly. Suddenly, operating systems were no longer static fortresses, but living organisms, gaining new abilities as the tech world evolved. Microsoft Windows, recognizing the power of the idea, also implemented similar functionality with its own driver model. This modularity unlocked enormous benefits. Hardware manufacturers could ship new device drivers to users without waiting for the next big OS release. Security teams could patch vulnerabilities or add intrusion detection modules without fearing downtime. Developers and tinkerers everywhere found their creativity unleashed. Research, prototyping, and real-world deployment all accelerated as modules provided a safe playground to innovate. Over time, the kernel module system became the backbone for supporting